It says that the diagram below shows a solid made from a semicircular cylindrical base. All right. So we're talking about a semicircular cylindrical base with a rectangular prism, yeah, above it. So you could see like a half of a jump, like a jerk pan jump at the bottom. And then we're seeing like a cuboid, which is a rectangular prism on it. And we're seeing the measurements. Be advised that this is 12, this is 12, this is 4, this is 4, this is 4, this is 4, all of these. So you're seeing all the measurements that you need right there. Now, what we want to do is to respond to the question. This says calculate the total surface area of the solid. They gave us a formula to find the cylindrical part. But remember, this is the surface area of one cylinder, but we don't have one cylinder. We have half of the cylinder. Look at this shape here. It's half of a cylinder. This, you know, half of a cylinder coming around here. It's half. So then we could use this formula and then divide it by 2, because it's half of a cylinder for the total surface area there. But we still have to think about what we're doing. So remember now, we're talking about the curved surface outside, all the way outside, the curved surface here on the other side, and these two semicircles here together. All right. So it's outside we're dealing with. All right. So let us put together those numbers. Because they gave me the formula to find that of the cylinder, and the cylinder is cut into 2 pieces, then I'm going to use this and divide it by 2. And then I'm going to be adding some other stuff, like I'm going to be adding this to it, which is the same thing around here. And then I'm going to be adding the 12 by 4, like this. I'm seeing this on the front. It's at the back as well. And I'm seeing it at the top. So I'm going to see the 12 by 4 3 times. So the 12 by 4, I will see it 3 times, basically. And I'm going to see the 4 by 4 2 times. And I'm going to add that to half of this for the curve, for the cylinder, because they gave us for a full cylinder. So basically, I'm going to be putting together these measurements as follows. So I'm saying, let me minimize the diagram a little bit. So surface area is going to equal to, I'm using the formula that I have right here, they gave me 2 pi r plus 2 pi r h. But definitely is half of this I need, you know. So if I need half of this, basically, you would see that if I could factorize out the 2 and then show you that half of it will just leave this and that. That's what half of it would have left, because it's 2. 2 of that, half of it is just 1 of each. So definitely for the semicircular part is 1 of each I'm going to be using. So then, since it is a semicircle, is a semicircular with a cylinder, then I'm going to be using pi r square plus pi r h. Then I'm going to be adding to that a number of stuff. 12 times 4, and it's 3 of them. And I have to add the 4 times 4, and it is 2 of them. Because remember, we're dealing with them. Let me move that. I don't want it to look like a square. And it's 2 of them. So that is what we're going to put together. Well, I'm going to put together my numbers. They didn't tell me what pi is. I'm just going to use 3.14. The radius is 2, because if you're seeing that this is for a diameter and it is 4, radius is 2. All right, so radius equal 2. And we're going to have to make sure that we don't overlook that. The radius is 2. So So I have 2 square plus pi times 2 times 12 plus all of this. I want to put together some values now. So 12 times 4 times 3, that's about 144. 4 times 4 times 2 will give me about 32. This front piece, 3.14 times 4 is 12.56. The next piece, 3.14 times 2 times 12, and I'm getting here 75.36. We're putting together all of these, and then when we're done, that's the total surface area. 12.56 plus 75.36 plus 144 plus 32. And I am getting 263.92, which is approximately 264 square cm. So basically, that's our answer right there. Good to go. Good to go. So that's the measurement question. So you have to think, look what you're doing. But I'm saying that you've got the formula to find the cylinder, but you'd have to see that it's half of it you need. Why? Because they tell you that it is a half of a cylinder that we're working with. The total mark for this paper was 100. This paper is marked out of 100. The multiple choice is marked out of 60, that's 160. The SBA is 20, that's 180. Next question says the volume of the solid. If I'm going to go the volume of the solid, I have to think about what I'm going to do. Think about this. The volume of the solid here. The volume. The volume of the solid is to find the area of the cross section, which is this shape. Area of this cross section. It's the area of this cross section times the length such that it reached all the way down here. We're talking about the cross section walked its way from one end to the other end, but the distance it walked was actually 12. So all I need to do, is just to find the area of that cross section and multiply it by 12, and I get the volume. Now, let's think about what we have. We actually have a semicircle here, which is I'm going to use pi r squared over 2. And I have a square because this is a 4 by 4. So this is 4 times 4. This is the idea that I'm going to multiply by 12. And that's it. Because we're looking at a semicircle plus a square on top of it. And it goes all the way to down this side. So we have to be thinking like that. So let us set up the thing and go. Let us set it up and go. So the volume being discussed there is going to equal to 3.14 times the radius square r squared over 2, because it's a semicircle. I'm going to be adding that to 4 times 4, which is the square part. And all of that will be multiplied by 12. You know what this concept is? This is my cross section, right? This is my cross section area. And this is my length. That is what constitutes volume. So let's go again. Putting this on our machine and work this out, I will get 22.28 times 12, which will give me 267.4 cm3. There you go. Doesn't get harder than that. Same concepts that you have been doing. You have to just put it together. So there it is. That's the volume. Now let's see what's going on now. The C part of the question, let me blow the question up a little bigger. So the C part of the question says, the solid is made from gold. So we're suggesting that that thing that you just saw is made from gold in such a way that 1 cubic centimeter of gold has a mass of 19.3 grams. You see how many cubics we have here? We actually have 267.4 cubic. They are saying one contains 19.3. All right. And then they're telling us that 1 gram is sold at $42.62. Then calculate the cost of the gold used to make the thing. No problem. First, I need to know the grams that made it up. So then the grams, so I'll just say total grams, yeah? The total grams is going to equal to the amount per cubic cm. So it's 19 per cubic cm, and then I multiply this by the volume I have, which is 267.4. So I'm going to find how many the total grams of gold now. So 19.3 times 267.4. And that is going to take me to 5,160.82 grams of gold. Yeah, that's the amount of grams of gold you need to do that. Based on the context, for every 1 cubic centimeter, it is 19.3. So we have to multiply that by the volume, which is 267.4. Now, here's the deal. For every 1 gram, it's going to be 42.62. Look how many grams I have. So the cost now, the cost is going to equal to the 5,162.82 times $42.62. 5,160.82 times 42.62. Because that is for 1 gram, and we actually have 5,000 something grams. My total, it's going to cost a lot. $219,954.15. All right. So that's it. That's it. That's it. That's it. As long as there is no error there, everything is good. All right. The concept came out properly. So that's what you were expected to do for the measurement, and that's where it ends.